Okay, so what I want you to do for your assignment is take the board as you've got it configured with the potentiometer, and I want you to add a LED and a resistor. So what you'll do is you'll go to we'll pick pin 9. So this is digital pin 9. Connect that there. Then you'll have a 220 ohm resistor, and then connected to that will be your LED, and then this will go to ground. So this is LED. Use a red LED. So you'll still have your potentiometer, which is connected to 5 volts. So separately from this, you've got your 5 volts, you've got your potentiometer and your ground, and then you've got this A2 connection. And what you're doing from here is you're getting a V2 reading. This goes between 0 and 5 volts. Now, what we want to do is we want to flash this LED, and we're going to use the delay time to do that. So the delay time is, we could start it off at 250 milliseconds like the video showed. But what we want to do is we want to update the delay time once we've started, according to 0 to 5 volts. So we want the delay to go between, let's say 1 second. So 0 volts corresponds to 1 second, and 5 volts corresponds to, let's say, 3 seconds. So it's going to flash at 1 second if it's turned one direction, and it's going to flash every 3 seconds if it's turned all the way the other way. So how do we do that? Well, let's think about that. So if we get 0 volts, we want 1 second. And if we want 3 seconds, it's going to be 5 volts. So the difference between those two is going to be 2. Now the one issue is that the voltage is going to be a float. So we might really want to use the other variable. So the number that goes from 0 to 1023, we'll use that instead. That way the delay time is an integer. I think he used delay time. So what we want is when it's 0, we get 1 second, and when it's 1023, we get 3 seconds. So the kind of equation that we need to come up with is 1 plus, we'll take this reading, whatever the variable was that we used for getting the digital number. So I forget what the heck that was called. Some analog something. You'll have to look at it on your code. The one that was used to get V2. We'll just call it analog val. And you can put in whatever it was assigned. It's the right hand of the equation after the analog read. So what you'll do is you'll have analog val, and you'll subtract. Actually, what you can do is you can take that and divide by 1023. So when this is 0, you'll get 0, and when it's 1023, you'll get 1. So we take that and we multiply by 2. So what that means is when you get 0 out of your analog read, you plug in 0 and you'll get 1 plus 0 over 1023 times 2, which is going to be 1. And when you put in 1023, you'll get 1 plus 1023 divided by 1023 times 2, and that'll give you 3. Now the only issue is that these are milliseconds, so we need to do 1,000 here, and 1,000 there, 1,000 here, and 1,000 there, and then we won't have to worry about converting it over to, so this will give you 1,000 milliseconds, this will be 3,000 milliseconds. So I think that's right. So when reading from the analog sensor 0, we'll get 0 times 2,000, which is 0, so we'll get our lower value, 1,000 milliseconds. When we get 1023, we'll have 1023 over 1023, which is 1 times 2,000, which is going to be which is going to be 2,000 plus 1,000 gives us 3,000. And then you'll have the delay time will get updated, and then you'll loop around, and then you can change your knob to another position. So basically it should blink 1 second once every second, or have a delay time of 1 second when it turns on and off, and it'll have 3 seconds when it goes the other way, and somewhere in between you should get about halfway in between, which should be 2 seconds. Okay, hopefully that is sufficient. You can go back and look at the programming for the blink program. You could steal some of that programming, do some cutting pasting to save you. You're going to have to do pin mode as an output for pin number 9. You're going to have to, what else are you going to have to do? You've already defined delay time as an integer, so you won't have to do that. And you'll have to do a digital write command, which will be either low or high. So like I said, go to, let me pull up the Arduino here. So if you need the coding for the blinking part, you can go to examples, basic blink, and here it's blinking the built-in LED. What you'll use is pin 13, and you'll have to define that up in the before the void setup. So you'll have a pin mode output, and then you'll have this delay time. Instead of putting in 1,000, you'll use the variable. And as long as you don't move the knob, it's going to keep the delay time constant. But then if you move it one way or the other, it's going to make the delay time longer or shorter. Okay, I think that's it.